Alright, today we are going to do how to find slope from a table. So when we have coordinates from a graph, we can put them into a table. But let's start with our graph. So let's say, let me draw a graph here. I'm going to put 5 tick marks on each side just to keep it easy. And I'm going to put more than 2 points, even though we've only worked with 2, because normally tables have more than 2 points. So let's say I've got one here, here, and I apologize, it's not going to be even, so I can already tell when I draw this line, it's going to be bad. Down to oof, that is nasty. Oh, because I didn't went to. I'm like, what is wrong? Okay, I got it. I was like, what is wrong? Something's wrong with that thing. Okay, here we go. I'm like, oh, oy. Okay. So, hopefully, and you might have already figured out the slope just by watching me graph it. But what's going to happen, just for today, we're going to compare our graph to a table, and I'm going to show you how you can find slope from a table. So we're going to go with a horizontal table. So when you go with a horizontal table, remember that's this way, X goes on the top always, and Y goes on the bottom every single time, okay? So let's start by writing our coordinates out, okay? So I've got 2, 4, 1, 2, 0, 0, and then -1, -2, okay? So to transfer these points into the table, you want to go in order from least to greatest. So look at your x's, okay? And you're going to start with your x's from the smallest x you have. So you have 2, 1, 0, -1. The smallest x I have is -1. Okay, so that's going to go here. Then his partner for y was -2. Okay, then here your next x is 0. That y is 0. Here, your next x is 1. His y was 2. Your next x is 2. His y is 4. So these are just both fancy ways, and I'll write them underneath so you can kind of see, but you don't need to. What the coordinates are in a horizontal table, which I feel like is more common than a vertical table, but we'll talk about a vertical table later. So let's talk about how to find the slope. Okay. So when we do slope, it's rise over run. Okay. And what that actually means, and we've already talked about this, but rising is your y and running is your x. So when you rise, you're trying to figure out your change in your y, so how much your y is changing and how much your x is changing. Change in y over change in x. Now for a graph, you know, it's easy, you just count. Now I have 4 points on here. I only need 2. So you pick whatever 2 points you want to find the slope. They'll be the same for all of them. So let's just say I started here and I rose 1 up 2. I rose 2, 1, 2 over 1. So rise 2 over 1. So 2 over 1 is the same thing as 2. This is a positive slope. So those both are correct. Okay? Now, let's look at it from the table perspective. So from the table's perspective, you're trying to figure out now how much your y's are changing by and how much your x's are changing by. Now these are linear, okay? And that's really important to know that they're linear. And what does that mean? They make a straight line. Okay, in order for something to make a straight line, you have to have a pattern that's the same thing, okay? So like when I did this line, my slope is 2 over 1. That means every time I want to put another point on this line, I would go up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, and so on and so forth. I can't go up 2 over 1 and then like up 3 over 1, because then my line eventually is going to start curving and then it's no longer a straight line. So you want to see, to tell if it's linear or not, make sure your x's are going up by the same thing and your y's are going up by the same thing. So look at your pattern for your x and your y, and I'm going to jump over here, okay? So your x's, the way I do this, I go, okay, how did I go from -1 to 0? I went up 1, plus 1. How do I go from 0 to 1? I plus 1. How did I go from 1 to 2? I plus 1. Okay? And then your y's, how do you go from -2 to 0? I plus 2. 0 to 2, plus 2. 2 to 4, plus 2. So I can tell these are linear because your x's all went up by 1s and your y's went all up by 2s. It's okay that x and y go up by different things, but I couldn't have like my x go up by 1, then 3, then 7, and so on and so forth, okay? So this is actually your slope. Figuring out what your x's are changing by, 1s, figuring out what your y's are changing by, 2s, is part of your slope. Now, this part is extremely important, okay? So that's why I'm waving my arms like a weirdo, because I get so many people that screw this up. Slope is rise over run, okay? It is change in y over change in x. Now here is the important part, okay? You need to look to see how much did your y's change by first. My y's changed by 2. That goes on top. My x's changed by 1. That goes on the bottom. Why is this so important? Because people see, oh, this looks like a fraction or whatever in the world they see, and they say, oh, x over y, okay, 1 over 2. My slope's 1 over 2. Except it's not 1 over 2. It's 2 over 1. Okay, so it happens a lot. I get kids that flip this over every time. So be very, very careful. It's y over x. And that's how you get your slope from a table. And I'm going to give one more example without the graph this time. Okay? We'll go over this again our next class period, but I just kind of want to show you without the graph, and then I'm going to graph it and show you. So let's just say, let's do we're going to stick with a horizontal table for today. So x, y. All right, and let's say x is, let's just say, okay, there's that. So -4, -2, 0, and 2. And let's say my y's are, I kind of want to keep it in range of where we're at. Okay, so to do this without a graph, remember, change in y, aka how much are your y's changing by, over change in x, okay? Rise over run. So look at your y's. I always I would start there first, okay? Because that's what you're going to do first. So your y's, -3 to 0, that's plus 3. 0 to 3, plus 3. 3 to 6, plus 3. Okay, so my change was 3. Okay, now my x's, plus 2, plus 2, plus 2, 3 over 2. And you can see if I graph this thing, so let me graph it real quickly. You have -4, -3, so that's here. Not the best alignment, that's okay. -2, 0. So -2, 0. 0, 3. And 2, 6. Okay, it's not a perfect straight line because I'm doing this by freehand. But if you were to do your slope, you'd count and be like, okay, up 3. 1, 2, 3, over 2, 1, 2. up 3, 1, 2, 3, over 2, 3, and so each, you can see that the slope, the dots were all spaced the same way, up 3 over 2. I'm gonna do one more example because I gotta throw a negative in there, okay? So let's say, and we'll keep it easy, one more example here. And we'll even do it without a graph at all. And let's see if you can do it, okay? So let's say your x's are doing, let's say 12, 9, 6, and 3, and then your y's are doing 0, 4, 8, 12. Okay, so start with your y's. All right, I like to do this, plus 4. And I just do this so I can tell that they all go up the same. Change in y is 4. Change in x. All right, we went from 12 to 9. That is minus 3. 9 to 6, minus 3. 6 to 3, minus 3, aka negative 3. So we'll work left to right here. So you have 4 over negative 3, and it's up to you guys, but I would put the negative sign on the top. It doesn't matter, but I know, again, when you type it into the computer, they want the negative sign in the front, not in the bottom like this. It's the same thing. Remember, I regrade it to look at it, but if you want an answer right away, put it in the front. But these are the same things, okay? So that's when you have a negative slope. So somebody might ask, what if your x and y don't go up by the same thing? What if it went 4, then 5, then 6? For this grade level, you're just going to say, then there's no slope, okay? Because this is not a linear line. You would say non-linear, all right? I think that's what we'll cover for now. I think that's good. So if you have any questions, please let me know.